Maybe I can show you how it looks like also before.
Okay, everyone. Let's continue. So at first we will take one question from the chat, and then I suggest that people from the audience can ask questions or have reflections. So the Zoom question was about the chat question was about rationality.
The chat question is about the relationship between what I call the relative rationality and Herbert Simon's bounded rationality. Of course, there is a very strong relationship. Actually, that's Simon's idea is a major source of my so-called relative rationality. But I think, in one sense, my restriction. First, we are moving in the same direction. That's for sure. Okay. His bounded rationality also say that when humans make decisions, they don't know everything. They don't have all the resources. He's basically talking about the same thing. Okay. But the key difference, I will say, 2 or 3. One is the additional, the restriction I put under the assumption of insufficient knowledge and resource is stronger than his restriction. So in my dissertation, I actually explain this in detail. If you say something is bounded, you typically say it's limited. But it can be bounded, but still sufficient at the same time. If you limit your problem you want to solve. Okay, I only have this much resource, so I cannot solve a problem here, but I can still solve a problem here. But when I say insufficient, that means you almost never have enough. Okay, just to reduce the scope of the task you want to solve, we will not get rid of this restriction. So this is one sense. Okay? Especially, you see, in Simon's definition, he basically addressed the finiteness in my definition, but he didn't mention the real-time factor, even though you can say he implied that. Okay? Also, he didn't mention the completely open to new problem, which he covered part of it. Say it can be beyond your current capability, but he didn't cover the situation. What if there are contradictions? So roughly speaking, yes, I think you can say this. My version is a stronger version of Simon's idea. That's one difference. Second difference, when he proposed this, even though Simon is one of the founders of AI, right? When he talked about this, it's mostly talking about human. You can check his literature. Even though this idea, of course, have influence to his AI research work. For example, heuristic search, right? You don't know the perfect solution, you try different ideas, and that's clearly in this direction. But in the concrete AI work, Simon himself involved, it does not really show too much restriction like what I put. And here, the 2 best known examples. One is GPS, general problem solver. That's his earliest work with Newell, which used the idea of heuristic search. But it didn't address the problem of, say, real-time restriction or, say, conflicts among the knowledge. It's not mentioned there. And his later work, probably the best known, is the Bacon system, which actually can be said to be the earliest kind of like machine learning or machine discovery approach work, which try to find regulations in data sets, try to rediscover, say, like laws, many laws discovered in physics and so on. If you check the design of Bacon, he basically didn't take any of the restoration into consideration. So that is my explanation about the difference. Even though I admire him very, very much, and I was influenced by his idea. I hope that answers the question.
Yes. There is one additional question about Act R that I think also fits the discussion.
Yeah, Act R is an interesting system. It's one of the oldest in my list. And also something about what I said about Simon is related to it, because this is also from CMU. Is initially a start production system very similar to SOAR, which is the follow-up of GPS. Okay, so they're kind of like in the same big family. Act R usually is not presented as an AI product, but as a psychology model, but is fully implemented in computer and try to use computer to simulate the human cognition in all aspects. Okay, because of that, I think there is a very large overlap between network and AGI, so I included in this. And also some of the Act R researchers are involved in AGI research, including one is in our editorial board of our journal. So whether you label it, it doesn't really matter. So what I think about it, do you think Act R is a good direction? I don't think so. There are several reasons. First, this is a very interesting thing. Second, what I have explained, and that one is too close to psychology for my purpose. I'm not saying they're wrong because we are pursuing different things. A third one is actually they acknowledge that in the description I cited in my webpage. Act R is more and more like a programming environment and platform than a system itself. Meaning that if you want to use it to simulate, say, a certain cognitive function, the psychologist or programmer or whoever, you still need to write code. Okay, so in that sense, Act R, the same thing applies to SOAR. They are more and more like a special purpose programming language. So it makes it relatively easy for you to build a model in their framework. But without that, it doesn't do anything. Okay, so this is very different from what we are doing. Is we start from a system and we train it and learn from its own experience and so on. We don't, code a model into it and later we take it out and we replace it for another. And this is well known by the Act R team themselves. One of the meetings. In one of the meetings, some of their researchers is talking about whether they can just use all the data or you combine all the models into one and make that part of the system. So you really have an intelligent machine or whatever you call it. So that's why, in a sense, another thing I didn't mention in detail is the relationship between the AGI community and the so-called cognitive architecture community. They're not the same thing. They're clearly not the same thing. Act R and SOAR are a typical example of the so-called cognitive architecture research, which exists much longer than the AGI community. Is much more mature. But what their major interest is build this overall structure, which will allow the system to do all kinds of cognitive functionality, but you need to write a module to put into that architecture. Okay, so that's very different from many AGI people will believe after you finish the building, you don't do any coding anymore. But you still need to communicate with it, as a form of training or education or whatever you call it. Some people may say, oh, that's a form of programming. In a sense, it is, but it's still quite different. But even though I said that the boundary between the two is not very easy to draw. And some people even say our project is just another cognitive architecture. Well, yeah, there's some reason to say that. So there's some partial overlap between the two.
Okay, so any questions or reflections from the audience? Yeah, David.
So thank you for a thought-provoking lecture. I was thinking about the definition that you have on intelligence, and when for us as humans, an important question is the meaning, meaning of our existence. Why are we here, and so on. And of course, the most fundamental thing is to survive and reproduce. And then when you talk about intelligence, the question is sort of what is the meaning, what is the goal? And I didn't find that part in your definition. So I was thinking, how is the meaning, the goal incorporated in what we call about intelligence?
Very good question. That's clearly part of the picture. But I didn't include it in my definition. Part of the reason is I want my definition to be as simple as possible. Then I will claim everything else can be derived from it. For your question, I think the concept of goal can be derived from the concept of adaptation. Because every adaptive system is moving to a certain direction or trying to keep certain property within it. Otherwise, you don't need to change, right? You change for a reason. So later you will see that in my discussion, every adaptive system is necessarily a goal-directed system. Whether that goal is realized by the system itself, or whether it's selected by the system itself or given from the outside, that's a separate story. You must have a goal, and which is absolutely true. I will say not only for my model, all AGI models have goals, but they handle it very differently.
By goal, in that sense, you would mean something like a system that tends, like even without itself being aware of it, tending towards some sort of energy minimum or some sort of like attractor thing.
That's one form, but that's not the form we're taking. Talking about goal, at least we can say that some special state attractors, that's one form. A more traditional form in AI, especially in symbolic AI, is a goal state. And you make action until you reach a goal state, which you can even trace back to the concept of Turing machine. You have a final state. That's your goal. In our system, a goal is defined by a bunch of statements you want to realize. You want something to become true. So later we will explain more. So on one hand, almost all systems have goal. On the other hand, they're handled, represented, processed very differently, at least currently in the AGI community. Say one typical example is some kind of variation of reinforcement learning model, where the goal is take the form of some kind of award function or fitness function or utility function, whatever you want, you call it. They try to maximize that. That's another form.
Can I make a comment on that page? Regarding adaptation, so for example, in psychology, it's sometimes distinguished between phylogenetic adaptation and ontogenetic adaptation. So the latter, ontogenetic adaptation, being really the adaptation during the lifetime, while phylogenetic adaptation is what has happened across of species, so to speak. And as a human being, then of course you have you have both those kind of adaptations running at the same time. We have goals derived from us being a human species present, like the needing to breathe and eat and drink and so on. But we also, as human beings, we learn stuff during lifetime and derive goals through that. And both of that is really present at the same time. And I think your concept of a goal really captures both of those.
Yes, actually, we are thinking about both, even though currently our adaptation is focused on the individual level, and the goals are given to the system from outside.
Yeah.
But you're absolutely right that if we have a relatively stable model for the individual, we do have the plan to talk about a group of those individuals, even though a species of this kind of system, which have generation to generation level of adaptation, which is typically called evolution. And we have talked about the difference and similarity between evolution as a species level adaptation and the intelligence at the individual level of adaptation. There's some similarity, there's some difference, and some of the goal, you're right, is built into the system by this evolution process. You don't learn it, it's given to you, it's in your DNA.
Yeah, and maybe that's also stresses the embodiment aspect of your model, that when we like think of it on a running system, like in the human case, it is we are embodied with the goals provided by evolution, so to speak. It's present. So maybe that the embodiment.
That clearly matters a lot. Later we'll see in our system, everything starts from sensor. If you have different sensor, of course, you will have different concepts. Of course, you will have different world view, and then everything else. You even have different goals, which is related to your sensation. But the model itself we try to build is kind of like a neutral with respect to different type of sensor. We actually handle the sensor and actuator in a kind of like plug and play manner. So for example, currently Patrick is using our system to run a robot. But the design should allow it to be used to control different type of robot, whether it have 2 legs or 6 legs or 4 wheels. Of course, that will make a lot of difference in the concrete knowledge, but the logic and the control mechanism should be the same. You just learn how to use your wheel or your leg. It's not built into the system, and the logic you use or the learning mechanism you use to do that learning, we believe are basically universal.
Actually, this small question that is this intelligence you're talking about dichotomized? Like the dichotomous is like whether the system it can only be 2 stages. It is intelligent or it is not. Or
It's a matter of degree. Later we will see we have a level structure,
right.
So we actually do it layer by layer. So at the very beginning, it's intelligent according to our definition, but it's not very intelligent. So each time you make it more and more intelligent in terms of what it can do and what kind of situation it can adapt to.
But it is accessible. Then right. Okay, that's a good question.
And also, for example, now we are also talking about to use it to model an animal. So that clearly that's a much lower level of intelligence compared to human intelligence. But we believe part of the model should be able to also explain that. So to a certain layer, you get animal, when you go up, you get human, something like that. But the basic principle remains the same, because animals also need to be adaptive to its environment, and also is bounded by the restriction of resource or knowledge, if we can talk about knowledge.
For example, you can assess like this bird can fly very fast because you know what is fast. Is that sense like, do we have like a standard what is higher intelligent? or-
Yes and no. We don't have an actual test yet,
No,
but
it's
we do
not.
have some principle. We do have some conclusions. Say, at least about our own models, we have already implemented many different prototypes. We can say this one is more intelligent than that one because of this or that reason.
Right, so it's more like a checklist. It's not actually quantitative scale.
It's hard to use a number to talk about it.
Yeah,
Yes,
it's
but at least we can say it's comparable.
Right.
And you can say this one is more intelligent than that one because of this.
To tick this box. Yeah.
So time is up. So the lecture is officially over, so to speak. I'm sure Pei will answer some more questions afterwards. But anyway, I just want to say thank you again, Pei, for doing this, and we give you.
Thanks for all the questions. Yeah. They will see each other in the coming weeks.
Yes.
So.